Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hey guys, welcome to a brand new episode of the Clear to Send podcast. I'm here today with Roel to talk about Wi-Fi capacity planning. Hey Roel, how are you?
I'm good. How are you?
I'm good, very good. So we've talked about this, you and I, a little bit, and we had a couple of questions around capacity planning as well. So we just thought we would just gather our thoughts and then record something about capacity planning, let you guys know what it is, why we need it in some cases, and I guess when you should implement it in your design work, and then give you a couple of tools you can actually use to do the capacity planning as well. And we have a list of gotchas as well, a couple of things you have to keep in mind when you do your capacity planning.
Yeah, because previous designs were all based on coverage, and nowadays it's all about capacity and making sure you design to the capacity, because coverage is already a given, right? We need to have coverage everywhere. Now it's about making sure you have the right amount of APs to provide service to everyone in the area, that whatever they're doing, on what applications they're using.
Yeah, you're right. It used to be like, RF design only, and now it's kind of like RF design and I guess capacity design. You want to make sure that you're meeting both your coverage and capacity requirements. But I would say the RF design still stays the most important piece. But your capacity study will come and adjust your design, might adjust the equipment you use.
Yeah,
especially type of antenna. Yeah,
you gotta use the right equipment. Excuse me, and I just think it's Wi-Fi capacity planning is actually more difficult than it sounds. Right? It doesn't. Yeah. It doesn't. It's not just all right, there's gonna be 15 people in here. I just need one AP, right? Like sometimes that might not be the case. And how do you even do the capacity planning to come up with the right number of total radios that are going to be used? I mean, there are these different tools, but some of them don't consider things like maybe co-channel contention and what kind of antenna you're going to use if it's not the built-in omnidirectional. There's so many other things to think about.
Yeah, there are a lot of moving pieces, and it's not as simple as that AP can support X amount of client devices. How often do you have questions from your customer, like how many clients can you support with this AP?
Yeah, they try to put X amount of people per AP. That means I should have, if I have 20 people, that I want to keep it to around 10 people per AP. But then now you got to think about, all right, how many devices does each person carry? And then if you have too many APs, how do you, that's the one question I ask people is how do you make sure, if you're going to put 4 APs in one room, because it's an open office layout, how do you make sure that X amount of devices go to a particular AP?
You mean the load balancing in between the APs?
Yeah, without turning on, say, load balancing.
Well, the vendor told me they had a load balancing feature.
That's another thing we should talk about too. What load balancing actually does.
Yeah. All right. In any case, let's start by talking about defining what a Wi-Fi capacity planning is, right? So I guess I can start, Roel. So when we're talking about Wi-Fi capacity planning here, what you want to do is pretty much study the different type of client devices that will be connected to your Wi-Fi, the number of devices that will be connected to the Wi-Fi. You want to study what type of traffic they will generate, so what type of application they'll be using on the Wi-Fi, and what you do is you compute all of that information alongside with how much traffic your APs will be generating, how much management traffic your AP will be generating. You compute all of that information and you try to find out how many APs you will need in order to support all of that traffic, all of these client devices in your space.
Yeah, that's a pretty basic explanation without getting too deep into it. I think that's the best way to start out. And the thing to consider here is you're really trying to determine airtime, right? You want to have the right amount of airtime available for all the clients in an area being serviced by your APs.
Exactly. So because when we talk about capacity of a Wi-Fi network, the first limitation we're going to run into is how much airtime we have available for all of our devices, right? And when we talk about airtime, it's just how it's pretty much how we look how we use the channel over time. And you guys know that in Wi-Fi, only one device can use the channel at one given time. So that's going to be our limited resource, and we're going to need to make sure that we have enough isolated channels to make sure that we can support all of this traffic, right? So we're gonna study pretty much how we use the airtime to try to determine how many radios we'll need, how many APs we'll need to support all of these devices. So if you look at exactly at what the capacity planner will do, the actual tool that you use to do the capacity planning. The capacity planner will pretty much estimate how much airtime each device will be using, right? And since you know how many of these devices you're expecting, you can actually do the math and estimate the number of radios you will need to support all of your devices.
Yeah. The other thing that we have to think about too is it's not just a simple math equation. You have X amount of devices. Let's just assume they're all gonna do YouTube 4K video. I need X amount of APs or radios. It's not that easy because you have to do other math that involves the type of devices. So when we talk about capacity planning, you have to consider the type of devices, their capabilities, because that also determines how much airtime they need to use for a given application.
Yeah, so to make it simple, like in order to estimate how much airtime a device will use, what we do is we look at two things. We look at how fast they can talk on the channel, right? So we look at their data rate, and we look at how much traffic they will be generating. So we look at pretty much the application they use, and we look at the bandwidth requirements of these applications. If we know how much traffic they'll be generating, and if we know how fast they'll be sending that traffic, we can actually estimate how much airtime they will be using to send out their Wi-Fi frames. Make sense?
Yeah.
So you're right, Roel. We're going to have to look at the Wi-Fi capabilities, because the Wi-Fi capabilities will tell us how fast the devices will be able to talk, will tell us the maximum data rate that these devices will be able to use. And that's something else that I guess we'll talk about again here. But when we do Wi-Fi capacity planning, usually we based our planning on the maximum data rate supported by the client devices. Even though in the real world, that
it's not
devices will not always use their maximum data rate, right? Based on modulation and signal strength and all of that. But in order to remove another moving target into the capacity planning, it's easier to just do it using the maximum data rate. And in order to find out what the maximum data rate of a particular device is, you have to look at its Wi-Fi capabilities, right? In particular, you have to look at which version of Wi-Fi they support, what the channel width they support, and the number of spatial streams they support.
Yeah. And there goes my like how I question capacity planning, because the devices are not always doing their maximum data rate, and there's so many other factors that determine the data rate. And that's why I think when we look at capacity planning, I'm going to take it with like as just a guide. I don't really use it as this is truly what's going to happen, especially when you're in an environment where there's other networks around, other people on the same channel. So the capacity planning is, to me, kind of a guide to get you see where you are, where you stand with your network. Best case scenario, yes, you could support this network to this capacity.
Yes, exactly. You could see it as an evolved estimation tool.
Yeah, don't take it as this is exactly going to work perfectly because you've designed it to this capacity.
and on top of using different data rate because of your modulation and because of the SNR or signal strengths you're getting from the APs, you also have to keep in mind that devices might, in order to save battery life, might decide to use only one spatial stream versus using two spatial streams, right? So that also will impact your data rate quite a bit. And that might also impact how fast the device can send their traffic on the air. So it's a lot of moving pieces, and sometimes we don't control all of them. So like Roel said, it's going to be an estimation of what to expect. But at least, I mean, if you do it, at least you have a little bit of awareness on what to expect. When you plan your Wi-Fi.
Yep. All right. So why do we do capacity planning? Like, why do we study this? And it really always comes back down to airtime. And because Wi-Fi is half duplex, that's something that you have to educate your clients on is
what Wi-Fi is half duplex in 2020.
I don't even think some people know what half duplex is.
When I tell people, I always stress the fact that we're still using half duplex in 2020, and it's just I don't know, it's normal. Everyone's doing it without knowing it.
Right, and then people think you're gonna get those numbers that's on the marketing data sheets, right? You get your 11 AXAP, and it says, on the 5 gigahertz, I should be able to do over 2 gigabits per second, right? And so at 2 gigabits per second, I mean that number looks great, but again, we have to look at airtime, how many devices are going to be using the Wi-Fi over that given area. And I like to, back when I was listening to a lot of what Andrew Van Aj was saying, is looking at that contention domain, right? The airtime for that contention domain. And we want to be sure that you don't saturate that contention domain. So you again, going back to design is going to be critical, right? So when we talk about capacity planning and what we do, it's all part of the design, and we're going to assume that design aspect is going to be good, and we're just going to focus on the capacity part. And so we want to know how many radios it's going to take in order to properly provide service to a given area without causing too much of that co-channel contention, or what people call co-channel interference. You could also call it, you don't want too many APs on the same channel operating in the same area.
Yeah, exactly. So I guess the danger you can run into when you want to design for high density Wi-Fi networks is just adding APs on top of APs, right? Especially APs with omnidirectional antenna, where the signal will go everywhere. And if you do this, what will end up happening is that you're going to have to reuse your channel more often, since you have more APs, and since these APs will be in the same closer to one another and seeing each other from the RF standpoint, then they're going to generate CCR, like you mentioned, and they're not going to end up reusing the channel. At the same time, they're going to end up competing for the same airtime and sharing the channel. So then instead of having, one AP and its clients on one channel, you're going to have 2 APs or more on the same channel with its clients attached to them, all sharing the same channel, all sharing the one lane road. And that's when you can end up into, reaching the congestion point of your channel, or reaching the 100% of airtime utilization way faster, because now you have more devices competing for the same airtime.
Right. They're basically on the same contention domain, rather than separating those contention domains and having that capacity for each contention domain. APs on the same channel are now under that same cone, right? So everyone has to share the same airtime. Everyone has to talk one at a time, especially the AP, right? It's not just the devices that have to talk, take turns talking. It's the APs themselves that have to transmit back to those clients. They also have to contend for airtime as well.
Yeah, exactly. And I get why, to go back to the why, why is it important to do capacity planning, is because if you end up in these situations, you're going to have to make decisions in terms of which equipment you need to use for your design, especially related to antennas. So one way to actually be able to reuse a channel and isolate those APs from one another is to use directional antennas. If you use directional antenna, the AP will kind of focus, the AP and the antenna connected to the AP will focus the signal in a smaller area, and it will also pick up other signals from that smaller area. So now you can actually isolate those communication on that specific channel in smaller areas, and you can start to reuse the channel more often in your space because you've isolated those communications, and that allows you to increase the capacity of your network by just changing, I guess, the type of antenna you use.
Yeah, I think equipment very much falls into this. I have done different scenarios where there's been classrooms that need to use wireless only, and they rely on that wireless for things like testing. And when I went into that environment, I remember I did a capacity plan because I started asking, all right, how many devices are you going to have in this room? They would do testing at the same time in 3 to 4 different rooms. And before I came in to redesign it to the capacity, they were all using omnidirectional APs in that room. So after I did the capacity plan, I identified, all right, what kind of application are you using for testing? What kind of traffic is it generating? Are they just receiving, or are they also sending traffic? And so it turned out to be audio, right? They would download audio, listen to it, respond, and record their voices, and that audio would be uploaded. And so I determined, all right, well, I'm going to use directional antennas in this environment to really make the laptops try to associate to the better AP, right? So if they were moving those laptops around, they would roam to the correct AP with the better signal versus picking one from a omnidirectional antenna down the room or down the hallway.
I guess that's another way to do load balancing, right?
Yeah. It's like instead of using the load balancing feature built in to the Wi-Fi infrastructure, I was just kind of manually doing it with the directional antennas. So, I mean, that's why we do those capacity planning, I don't want to use the word survey, but like studying that capacity planning, how the applications are going to be used, the devices, and they were Chromebooks, so I knew what specs they had, and I knew from that how many APs I would need per room with directional antennas in order to have more of a stable test when they were using those laptops.
Exactly. So you can use the data coming from the capacity planning to refine your RF design and see if you need to change the type of equipment you need to use, if you need to add APs, and then as you go back to your RF design, try to arrange it. If you see that you're not able to meet both the capacity and the RF requirements using omnidirectional antennas, that's usually when I start to use that. Using different directional antennas, and that's when you can try to study, okay, what type of directional antenna would be the best for my situation.
Okay, so when we talk about then the studying this capacity and how much capacity is needed, when should you actually do capacity planning? Like, is there a threshold for installs? Like, if it's like 10 devices or more, or a given scenario, is it open spaces? Is it high density scenarios? What's your take on it?
I was going to say, as a lot of things in Wi-Fi, it depends. But saying it depends is not enough. You have to say it depends on what. Yeah. So it depends on how many. For me, it depends on the density of devices. How many client devices you're expecting to have in a given space, right? It also depends on the environment. Is it going to be open space where the signal will go everywhere, or is it going to be, or are you going to be designing Wi-Fi for a place where you have a lot of walls and a lot of things that will attenuate the signal? That might impact, the way you do the need for capacity planning. And then you need to understand, okay, what type of traffic will be generated by these devices? Because you could have a lot of client devices, but not really being active on the Wi-Fi. And on the other hand, you could have a lower count of devices, but because of the nature of the work they do, they heavily using the Wi-Fi. So you kind of have to compute all of that information and understand what type of environment you're dealing with. And I guess going back to the Wi-Fi design, that's actually a critical piece of the Wi-Fi design is understanding, the requirements. Right. Understanding the environment, understanding what your customer is trying to achieve, or what the user will be, how the user will be using the Wi-Fi, and try to understand if you need a capacity planning or not. So to answer your question in a more direct way, I guess, because I just did a whole bunch of talking, probably sounded like a politician. For me, if I see open spaces with a higher density of client devices, so if you think about airports, if you think about convention centers, obviously, stadium arenas, or if you see, even an office environment that's very open space with a high density of devices, then I will usually do a capacity planning. And if I'm dealing with very specific applications, right? If I'm I remember designing for like a studio space, where they were using a lot of video traffic and streaming, and they had a whole bunch of marketing tools that were using video streaming. So in this type of environment, I know the Wi-Fi will be heavily used by these devices. So you want to do a capacity planning. I know you work in offices environment where you have a lot of laptops generating a lot of traffic as well. So that could be another good example of doing a capacity planning.
Yeah, for me, it's when I would do capacity planning, again, to not try to use the word "it depends." It always goes back to talking to whomever is going to be like the technical person for that environment, and understanding, all right, what are your requirements here? What is the most important thing to you of this wireless network? What are the critical applications that are going to be used, and how are these people going to be working over Wi-Fi? So when I look at an open space, generally I look at capacity planning if they say almost all these people are going to be working over wireless only. There's no Ethernet drops. So that's when I go, all right, well, we should really do some sort of capacity planning in this space. So I determine how many people are going to sit there, what kind of devices are going to be there. Like that's when I do capacity planning in open spaces. If I know there's going to be an Ethernet drop at every single desk, and people have adapters for Ethernet or docking stations, then we know that they're not going to be fully over Wi-Fi. There's going to be some like in higher education. I know people probably think capacity planning is much more difficult in education because of a BYOD environment. And so in that case, I would use my existing network management tools to determine what kind of devices do I generally see over the Wi-Fi network, and then try to narrow that down to that specific area that you're looking at, and design capacity to the most commonly used devices in that area. Looking at how people use wireless, I've sat in classrooms and lecture rooms and I sat all the way in the back and I looked at what people were doing while a professor was teaching everyone, right? So I would see, all right, I know what applications a professor wants to use to do his teaching, to tell people what to do. And I know what students are doing when they're not paying attention. So I will design to capacity to make sure not just web browsing and, simple clicks of websites, but also accommodating the X number of people who are going to download video, like YouTube, right? There's just going to be people you have to consider applications that are not mission critical, and also know that, all right, if you look at an office environment, a lot of people listen to audio, right? Audio streaming. They play videos in the background, you name it. Like they do all sorts of things. And then if you're using mostly Apple devices, they're probably using, what is that software called? To back up all their stuff, right? So there's always a lot of upload too when they're either uploading or even downloading software updates. There's so much to consider. So I know in higher education, capacity planning is a little bit more difficult to do, but in certain classrooms, you can do capacity planning, and that's where you have to get a little bit more creative in your design and use, say, directional antennas. Right. So,
I want you to circle back on, when you actually talk to the users and try to understand what they'll be doing on the Wi-Fi. When you do that, most of the time, the users tend to overestimate the use of the Wi-Fi, right? So you'll come up in a classroom and you'll ask them, okay, how many devices are you expecting here? And they will think about, okay, I'm expecting maybe 60 students, and each student have like 3 devices, and so it's 180 devices, and you're thinking there's no way all of these 180 devices will be connected to the Wi-Fi at the same time, right? First of all, you don't know if students will be coming with 3 devices. Right. Some of them will be coming with just 1, some of them 2, maybe some will have 3. But that's just like I guess that's an overestimation. And then on top of that, when students come into the classroom, they won't have necessarily all of their devices connected to the Wi-Fi. And even if they do, none of them will be actively transmitting on the Wi-Fi. So you kind of have to, you kind of have to look at all of this and incorporate that into the study of your capacity planning. So that's usually when I try to set the expectations with the customers. And the best way to do this is to ask them how much traffic they're seeing on the APs right now. If they look at the Ethernet cable that's connected between the APs and their switch, and they look at the utilization of how much traffic they have on these links, they usually get the idea pretty quick, because it's usually lower than what we think.
Yeah, when you look at capacity planning, you probably won't be planning to 100% active clients, and I mean like 100% of the time. You're not going to see all of those clients doing exactly the same thing at the highest capacity, right? So I think that's very small use case. I would say maybe even in my examples, the classroom environment's probably the best case for that. Actually, I did have one scenario where they said it was like 12 students, and you would think, 12 students over a laptop, 1 AP, no problem, right? When I talked to them, they told me what kind of applications they were using, because they told me the Wi-Fi was very slow, and it was being serviced by 1 AP. And I found out they were using GIS applications, so a lot of application that uses downloads a lot of data and does data based off of like Earth, and I don't know. It's basically a lot of data that they download, and they would open also while they're doing that, open a web browser because they know the download takes a bit. Open a browser and go to certain websites that actually generate a lot of traffic, and so I ended up from one access point omnidirectional to about 3 APs with directional antennas, trying to shape different contention domains based on where students were sitting. And that ended up working. Like, that was not a typical scenario where I would see that, right? Or you would design for that, where you have one corner of a room that's got 3 directional antennas.
No. Yeah. So I guess, that's something to talk about with the customers and try to set the expectation. And something you can do when you do your capacity planning is you can actually specify those, ratio of connected devices versus active devices.
Yes.
So you could say, out of my 180 devices, I'm estimating that 60% of them will be actually connected to the Wi-Fi, so associated to the Wi-Fi. And then out of these, 60%, I would say maybe 30% will be actively sending traffic over actively sending traffic over the air. And you can use those numbers to do your capacity planning.
Yeah. Even then, I have trouble with the number of actives, because it's not all. So let's say there were 100 devices and you said 60 of them are going to be active. It's not like all those 60 devices will be active at the same time downloading
they were sharing.
Traffic is usually bursty traffic, so it's typically here and there that they're downloading or uploading.
Yeah.
So when you even do that, it's still kind of at the worst case scenario if all of these devices started actively doing something over Wi-Fi. At the worst case.
Yeah, I guess it's a perfect transition to some of the gotchas we wanted to talk about. Right before that, I wanted to mention, we talked about when to do a capacity planning. Let's talk briefly about when you don't need to do a capacity planning. So, for instance, in a warehouse environment, usually you don't need to do a capacity planning, even though that might change with, Industry 4.0 and all the new stuff they're incorporating in the warehouses. But as of today,
generally right now,
we don't do capacity planning because usually we don't have a high density of client devices. And we're going to have a lot of APs in the warehouse, right? We're going to use directional antennas in a warehouse, but for different reasons.
For roaming and to help clients.
High ceilings.
Because you're going to be mounting those APs pretty high up, and in a warehouse without using directional antennas, it could be more detrimental when you add a lot of APs.
Yeah, so I just wanted to say that. All right, so let's move to a couple of things you have to keep in mind when you do the capacity planning. I think we've mentioned most of them as we just went and talking about it, but the first one is, capacity planning. The way we do it today are estimations. There are a lot of moving pieces. So you just have to keep that in mind. It gives you an idea. It's not going to be exactly what you will be seeing in the real world. And usually when we do the capacity planning, we try to plan for the worst case scenario.
Yeah.
Right. So you plan for, going back to that classroom example, you plan for a full classroom.
Yeah, exactly. It's by all means an estimation, but just remember that some of these capacity tools really do plan for full capacity. If you're going to put in 100 plus devices in that capacity plan and say, give all of these devices a 10 megabit per second SLA, it's going to assume all of those devices are going to use 10 megabits per second.
Yeah, that wouldn't be realistic to me. That would give you way too many APs.
Yeah, so I think that's a gotcha if you're trying to design something and then you do a capacity area and you say, like a good example here in the Bay Area is like there's these all hands meetings, right? Where everyone just goes to the same room and they have this meeting. And usually the client tells me, a lot of people bring their laptops into this meeting. They're going to be using wireless. So there's a lot of people here. We're going to need more than 4 APs in this room that really fits a capacity of like 50 people. And I go, okay, what are they doing on their laptops during the all hands? Like, are they not paying attention or are they doing their own thing?
Are they streaming 4K Netflix?
Are they all watching the video as it's being played in the same room? So like, it's those types of questions.
Sorry, there's a delay. I didn't catch what you said. Can you repeat?
So like, it's those kind of questions you have to ask. And it's not necessarily like, if there's going to be 50 people or 50 devices, not all 50 devices are going to be doing the max capacity, right? They're not going to be doing all of the traffic as the capacity planner says. It really is a bursty kind of traffic unless you have a very specific scenario. Again, you got to study it.
Exactly. And, as you do the capacity planning, you're going to realize at one point, you're going to see if you're over-engineering the solution or not. You're going to have a sense for that. And so you can use your judgment to see, what you will really need to make it work.
Yeah.
And as you do those exercises and as you implement and see the end results, you'll get better at it. But I would say at the beginning when I was doing it, I was definitely over-engineering.
I think most people over-engineer it, to be honest.
Yeah. It's kind of like the same with a wired network, right? We always tend to over-engineer.
Right. You have to do some sort of capacity planning on the wired network, right? How much bandwidth are we going to need on the wired network. We need to treat Wi-Fi kind of similarly to the wired network and do the planning and be able to right size it with X amount of growth, right?
Exactly. It's about finding the right balance. You could over engineering. The issue is that you might have to deploy a network that's expensive and not really suited for your needs. So you kind of have to find the right balance.
Yeah, but
between something that will fit your needs, but at the same time not be crazy over engineering.
Right. But when you over engineer a wired network, you really usually don't have a negative impact, which the only negative impact to over designing a wired network, I believe, is just money. When you over design a wireless network, there are other issues you'll have, especially around airtime and co-channel interference. Like there's a lot of other issues you can have over engineering it, the Wi-Fi.
Yeah. Second thing that you have to keep in mind is, and you touched upon that, is how do you do the capacity planning if you don't know exactly which devices will be connected to the Wi-Fi, right? Yeah. So going back to that BYOD, because that's a question I had, when I showcased this. In the capacity planner tool, you actually have to define exactly which devices will be connected, right? Yeah. And then people go back to me and they're like, I don't know which devices connects to my Wi-Fi. So in those BYOD environment, like you said, higher education or public venues and so on. So I do exactly what you've said. So I ask the customer if they have some sort of management system and if they can get some stats out of it, telling me today, what's the situation? What type of client devices do you see? And try to get some sort of statistics in terms of, the capacity of the Wi-Fi devices connecting today to the Wi-Fi network. And then I take that data and I might tweak it a little bit to make sure it's future-proof. And then I use that estimation to do the capacity planning. If the customer tells me I have no idea, I usually have
it's usually the answer.
Yeah, it's usually the answer. What I do is I have a client mix that I use. So I would say, X percentage of client devices will be 2 spatial stream, 11 AC, right? X percentage will be 1 stream, 11 AC. X percentage would be 2.4 only. And then, so I have this client mix that I use when I have no idea. And this is just a client mix I've used because that's what I've seen for most of the Wi-Fi I've worked on. So I just use that as a baseline, kind of, and I kind of tweak it and change it once a year about to make sure it stays accurate. But once again, you're adding another estimation in the estimation.
Right. It's all guesstimates, right? So if you have that information via your network management software, if it could tell you the breakdown of clients, you take that number. If that's like, X amount of 3 by 3 by 3 devices and 2 by 2 by 2 devices, then look at the room that you're trying to do capacity planning for. Look at what the max capacity is, like people wise in that room, and then use the same numbers. Like if you look at the network management system and you go, you know what, that's like, well, after you get requirements, like most of the time, if you get requirements, you can determine, all right, I would expect people to use laptops in this room and not so much mobile devices, but you could still use your network management to go, all right, well, maybe out of this room, if there's 100 people, 60% of the people will use laptops. 20% of the time, there's some mobile device usage. And then so you can try to get closer to the guesstimate in order to figure that out, right? And it's going to be something that requires some massaging. You are guessing a little bit, but it's BYOD, so you're not going to get 100% requirements there.
Did you hear my Alexa speaker?
I did.
Yeah.
Did I trigger it?
Because I was trying to get the client mix and then put it in the show notes to show you guys, and then my laptop just decided to wake up, and then Alexa is like, speaking French to me. Anyway,
She tried to chime in on capacity planning. She probably knows what to do.
She knows. She's listening to us right now. Or at least me. She can't hear you, but
Oh, that's true.
she's probably guessing with AI what you're saying. So I'll find the client mix and put it in the show notes for you guys, so you can have an idea of what I use. And something I wanted to talk about too is capacity planning for Wi-Fi 6.
Oh, yeah.
Yeah. So that's going to be even more complex. I don't think
there's any tool
possible.
Maybe Ekahau and IB Wave can do it, but I don't think they're considering a lot of the Wi-Fi 6 features and functionality with OFDMA. I'm not sure if those algorithms that included in our design applications consider that in capacity.
No, not today, but these will, the new features such as OFDMA or BSS coloring, multi-user MIMO if it's used. All of this will impact capacity, but that will make the capacity planner really complex. And on top of that, it will depend on the implementation of these features. Like, we would have to know exactly how Cisco implements OFDMA, how Aruba missed to implement OFDMA, and most of the time I think we're not going to know exactly how it works. So they're going to have to reverse engineer, I guess, or do a lot of work to.
That's a lot of reverse engineering. Yeah, because when we talked about Wi-Fi 6 in our series, going through the draft, it looked like they were giving vendors a lot of leeway into how they could implement the OFDMA. And so there is no hard set rule of like how you're going to split those subchannels per device. Yeah. Right. So that's going to be a big challenge. I think if we design how we design today for capacity, the OFDMA will just kind of be like you get an extra plus. Yeah. You get that extra oomph out of the Wi-Fi network.
Yeah. So at this point you start to ask yourself, is it really required then for Wi-Fi 6 to do capacity planning, or is it worth the effort to develop a capacity planner for Wi-Fi 6? Though, I mean, the whole point of Wi-Fi 6 is to make it more efficient, so increase the capacity of your network. So, I mean, like you said, I think if we just keep on doing the way we used to do it, we should be fine. And for the most part, we're still going to have a lot of legacy client devices on our network for a long time. So
I was just going to say the requirements aren't going to say these are all Wi-Fi 6 clients. So therefore, you're going to be designing capacity to older devices, Wi-Fi 5 and older.
Exactly. And that might change with 6 gigahertz, as 6 gigahertz will only have Wi-Fi 6
devices. We're going to need capacity planning for 6 gigahertz. It's just everyone gets a channel, right?
Yeah. I guess we'll see, but I don't think we need it right now.
No, not yet. No.
We'll see how it plays in the future. Something else you have to consider is capacity planning have to be made for specific areas or for areas of same density. So if you have like, let's say, a school, and you have if you're expecting different density of devices in different area, you can have to do this study per area, which can become very tedious.
Oh, I see.
To do.
Okay.
Yeah. So let's say you have an auditorium, you're expecting 200 people, and next to that you have another auditorium where it's the same size, but you're only expecting 100 people.
Yeah.
So they're not really gonna have the same requirements in terms of capacity. So you can have to do 2 capacity studies, which, like I said, is not really scalable and is not really. It can be a tedious work, and that's why it's easier to do. Yeah, I was gonna say it's easier to do capacity planning if you do it within a site survey tool. I shouldn't say site survey, but a planning tool.
Yeah.
Such as Ekahau or IB Wave, because they can actually do that. They can actually define different areas with different capacity requirements, and they can actually do the math for you per area.
Yeah, you can have an area within an area. So if you're looking at, higher education is a good example of this, where you've got a building, there's office space. So you would create an area for the whole floor, but then in the middle of that floor, there's a large auditorium. So you create another capacity area for that auditorium and you go, I want to design for this capacity in this section here because it's an auditorium. And it may have different ceiling heights for the APs, you know, you just got to consider all that.
I even seen an auditorium that goes over 2 floors.
Oh,
you have that in your environment? Where,
yeah, we have that.
So yeah, makes it even more interesting. Yeah, so these are a couple of gotchas. We also had, the saying that, maximum device capabilities are used for the capacity planning, but in the real world, you're not ending up using the maximum. So I guess that kind of balance it with, us over engineering it on the other end. So like I said, you kind of have to find the balance and see what you get as a result of your design.
Yeah, just be very cautious about the maximum device capability when you're doing that in your design application, because you could end up with, I don't know, a small room of like 60 seats. And then if you've over designed it to the capacity, you could end up with, say, 8 APs within 10 feet of each other. Like that could be a problem.
Yeah, that sounds way too much.
It's way too much. When they're that close to each other, like that's where I go, how are you going to split the devices amongst each AP? Like it's not like when a device goes into the room, the APs go, all right, who's going to take this device?
Okay.
Which you can't do because the device is the one who picks.
It just clicked in my head for me because I know exactly what you're talking about.
It's hard to explain over audio. We need to actually show it.
Yeah. All right. So how do you do those capacity planning? So you have different tools available to you. You have the capacity planner from Revolution Wi-Fi from Andrew Van Nage. So you can go on his website, revolutionwifi.net. And then you have on the top right-hand corner of the website, you have this capacity planner, a link, and you can download it. And when you download it, you actually get the capacity planner, which is an Excel sheet, and you also get a PDF that explains, what the capacity planning is and how to use the capacity planner. And it's quite extensive. So if you want to actually learn a little bit more about all of this, you should read the guide. It's like 40 pages.
Yeah, it's a really good guide. I think Andrew's, when I first learned how to do capacity planning, when he came out with those videos, I would watch them repeatedly because Andrew knows the math pretty well, and I use the capacity planner even to this day as kind of like my main capacity planner, and I just kind of augment it with my design application.
Yeah, what's really good with his planner is that it's very detailed, so you can be very granular with it. And you have a first section where you detailed everything related to your Wi-Fi environment, the Wi-Fi infrastructure. So you would detail which AP you're planning on using. You would detail, the minimum data rate. You will detail how many SSID you want to support. Yeah. You will detail
how many clients you want on 5 gigahertz versus 2.4. Room for growth.
And then the ratio we talked about, right? Connected devices versus associated devices. So you can actually go down.
That's why I like his planner, because I know I can put down how many devices are going to be in the room, but you could get a little bit more estimated with the amount of devices that are actually active versus just associated. And so that gets you a little bit more realistic numbers for how many APs you would need. And you could compare that to something like what Ekahau shows you or what IBWave shows you, and you'll see that there's a difference in the number of APs that are required.
And the only limitation though is it doesn't, you don't have a map on that tool, so you kind of have to do it per area. I
use it per area, not for a whole floor.
Yeah, so then you would take that data. So the tool pretty much tells you how many radios you need, 2.4 radios and 5 gigahertz radios you need for that specific area that you're studying. And then you can take these numbers, go back to your planning tool and try to see if you can make it work. So that's the first tool. And then Ekahau and IBWave, they have their own capacity planner tool built into their planning tool. so Ekahau Pro and IBWave Wi-Fi. And then what you could actually do on their tool is define, per area, the number of devices, the type of devices, and also, the type of traffic that will be generated by these devices. And then they calculate the airtime utilization based on the APs you've placed on the map. And then they let you know if they let you know how much airtime you're using, pretty much. So they let you know if you have enough AP or not.
Yeah, and I find that Ekahau Pro, when you're doing the capacity planner, it's to the max capacity, right? So if you're going to put 100 devices at 10 megabits per second, it's going to assume they're all going to do that at the same time. So maybe that's like a request, ESS request we could make is kind of like what Andrew's planner has, is be able to say what percentage is active, what percent is associated, or maybe a combination of both. Right now, I kind of manually do that, where I go, all right, there's 100 devices. It looks like there may be 60 of these that'll be active, and the other 20 might have a lower SLA, for example. Like maybe instead of 60% of those devices, 60 of those devices will have 4 megabits per second, and then the rest will have 2 megabits per second.
Yeah, I do the same thing, and then I use the area notes to just document that. I would say, 100 devices expected in this area, 60 of them will be connected.
Yeah.
Whatever. So I'll use that to document that information. But it would be nice to be able to play with those ratios within the application. You're right.
Cool.
Yeah. So, and then also we didn't mention it, but in those applications as well, Ekahau and IBWave, you can also define anything related to the infrastructure. So you can define obviously the type of AP you want. You can define the number of SSID. You can define the minimum data rate and the band distribution as well.
Good stuff. I mean, there's a lot more to capacity planning. I think we just kind of touched the surface of what was in our minds and how we approach it. There's an actual practical way to try to do this yourself. I mean, we could go through the applications and show you how we do it, but
we could do a live
we could probably
if you guys interested one day. Yeah.
Yeah, I can take an example of what I've done in an environment. We could run through it. Like you can run through yours, I can run through mine, and then we can talk about, like, maybe ask questions like, "Oh, what about this?" or "Why'd you do this?"
And I guess the best way to, I think for capacity planning, the best way to actually get your head around it is to actually do it. So try to see if you can actually
try doing it manually
for one of your work. Try to do it manually. Did you say?
Yeah. I've tried it before, like learning the math and try to figure it out yourself. I've done it.
Yeah.
I've done it before a long time ago. And then once these applications got more advanced, I was like, forget it. Like I'll let the application get me there. And then I'll determine, use my own judgment, my best judgment based on how I know the environment and how the applications are going to be used.
Yeah, I guess we didn't mention, but if you want to actually learn how it works, you could also check the airtime calculator from Garamond.
Yeah,
it
that's
shows
true. Yeah,
you
we should add
how
a
the
link to
airtime
that.
is used.
Yeah.
Yeah.
Yeah, because you could take Garmin's airtime calculator and look at Andrew Van Aj's capacity planner, and you should be able to determine the math behind it. Because Andrew's planner is an Excel sheet, so you should be able to see like how those values are created. I believe. I think.
Yeah. It's a really nice way to visually see how the airtime is used, and you can connect the dots.
Yeah, exactly. And that way it's just more of a education for you, right? You understand what is involved to create the capacity.
Yeah, I guess that's how I see the airtime calculator from Garamond. It's like a very good educational tool and you can also use it to showcase stuff to your customers, right?
Yeah.
You can actually visualize the amount of overhead we have in Wi-Fi. And you can showcase that to your customers.
Yeah, I'm trying to see if I can see those values. I don't think you can on Andrew's sheet.
I'm not sure. I've never tried to find them.
Well, if you just look at it, you might be able to, because everything's there. Everything is calculated on the Excel sheet, so you may be able to just try to create the math yourself. But yeah, look at those sheets. Math is the harder part for me, so I don't even try that much to. I trust Andrew. It's worked for me, so I know it works.
And Germont details the math in his.
Yeah, he does. He even did a presentation on it. WLPC
exactly.
Prague.
So maybe we should put the links to the different presentation, the one from Germont, the one from Andrew, and you guys can take a look at them if you're interested.
Yeah.
I don't know.
Yeah.
All right, I think that was pretty good.
Yeah, that was good.
Let us know. Yeah, let us know if you do it differently. Let us know if you're implementing something in your capacity planning. Let us know if you're doing it or if you're not doing it, right? And why.
What are your tips?
Would be interested.
All right, thank you guys.
All right. Yeah, so if you want the show notes, you can head over to cleartosend.net/226, and you'll be able to get all of that information. Thank you guys for listening, and we'll be back next week with a brand new episode. Have a good week.
Bye, guys.
Bye-bye.